All right, find the point of intersection of the pair of lines below if one exists. So we need to find the solution. We want to find where these two lines intersect. So I notice right away that my variables are lined up. That tells me that I'm going to want to use the elimination method. I already know if I add these two equations together, positive x and negative x will eliminate. They'll go away. So I'll only be left with y's. So if I add positive x and negative x makes a 0, those cancel out. We're left with 5y plus 2y is 7y. 8 minus 1 is 7. Then we can divide by 7 on both sides and we get y equals 1. So remember, we're not done yet. We need to find the x coordinate. So if we know y equals 1, we can take it and plug it back in to find the x coordinate. So x plus 5 times 1 equals 8, which is x plus 5 equals 8. I'll subtract 5 from both sides, and I get x equals 3. So the point of intersection of these two lines is 3, 1. Graph the solution to the system of inequalities below and name the coordinates of 5 points that make both inequalities true. So the first one is x plus y is less than 7. So this is not in y equals mx plus b form, so we have to put it there by subtracting x from both sides. So we get y is less than negative x plus 7. So I'm going to start at 0, 7. Negative x means we go down 1 to the right 1. And we have a no equal sign right here. It's just less than. So we're going to use a dashed line. And we want the y values that are less than the line. So we can put our pencil on the line and shade below it. So all of these values. For the second equation, we want to start at negative 3. And we're going to go up 1 and to the right 5. Again, also no equal sign, so we have a dashed line. And we want values that are less than the line, again. So we shade below. So the place where both lines are shaded is where a solution is going to be. So that's all of these points right here. So we have to name the coordinates of 5 of those points. So let's see, one of them is, I'll use my marker. Let's see, we can do this one, 1, 2, 3, 4, 5. All of those points are solutions. I could pick any point that I wanted, but I'm just going to pick those 5. So the first one is negative 1, 2, 3, 4, 5, 6, negative 1, 2, 3, 4, 5, 6, 7, 8. The second one, 1, 2, 3, negative 3, negative 1, 2, 3, 4, 5, 6. The third one is 0, negative 1, 2, 3, 4, 5. The next one is 1, 2, 3, negative 1, 2, 3, 4. And the last one is 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, 6. In a previous homework, you determined that these two equations would tell you the number of touchdowns, so for T, and field goals for F that the fabulous footballer scored in their game. Solve this system of equations using the substitution method to figure out the number of touchdowns and field goals that the team scored. So I notice that we have F by itself here. So we can substitute 2t plus 1 in for F in the other equation. So we get the new equation 7t plus 3 times 2t plus 1 equals 55. Now we'll solve this equation. First I'll distribute to 2t into 1. So I get 7t plus 3 times 2t is 6t plus 3 times 1 is 3. 7t plus 6t is 13t. Minus 3 from both sides. 13t equals 51. And divide by 13 on both sides. And we get that t equals, I think it's 3. 3 times 10 is 30. 3 times 3 is 9. No, that's not right. (51) divided by 13 is 3.9. Let's see, if that's not right, maybe I made a mistake somewhere. So let's see, I plugged in 2t plus 1 in for f, and I got 7t plus 3 times 2t plus 1 equals 55. Then I did 3 times 2t is 6t. 3 times 1 is 3. Oh, I see my problem. 55 minus 3 is not 51. 55 minus 3 is 52. So 51 divided by 52 divided by 13 is 4. That makes more sense. So the number of touchdowns was 4. Now that we know t equals 4, we can plug it back in here. So we get f equals 2 times 4 plus 1. So f equals 9. So 9 field goals. That's a lot of field goals. Solve the following inequalities. So for an inequality, we solve it the same as an equation, except if we divide by a negative or multiply by a negative. So we'll talk about that if that comes up. So first we'll add 4 to both sides. We get 3x is greater than x plus 7. Subtract x from both sides. 2x is greater than 7. Divide by 2, and we get x is greater than 7 over 2, which is also 3.5. So any x value that's bigger than 7 over 2 is the answer to this, or makes this inequality true. For the second one, first I'm going to distribute this negative. So we get negative 2x plus 3 is less than or equal to 8x. And then negative 6 plus 11 is 5. So next I'll subtract 8x from both sides. So we get negative 10x plus 3 is less than or equal to 5. We'll subtract 3 from both sides. Negative 10x is less than or equal to 2. Now we divide by negative 10. And when we divide by a negative, we have to flip the sign. So we get x, instead of less than or equal to, it's going to change to greater than or equal to 2 over negative 10, which is negative 1/5. And then the last problem are some diamond problems. So these are the same as we've done in the past. They just look a little bit different. They don't have the diamond drawn in, but they still have the x in the middle. So 10 times negative 8 is negative 80. 10 plus negative 8 is 2. Negative 6 plus 9 is 3. Negative 6 times 9 is negative 54. Negative 8 times 11 is negative 88. Negative 8 plus 11 is 3. Negative 8 times 4 is negative 32. Negative 8 plus 4 is negative 4.